Howdy, this is Mr. Potter. In our last video, we started creating our fraction class. We talked about our instance variables, we talked about our parameters, numerator and denominator, and we made them private, which meant that no one could really access them from the outside. And we also created constructors. We had two different constructors. Our default constructor, which is our very basic, simplest fraction, just a fraction like 0 over 1. And our default constructor, and our overloaded constructor, this constructor that allows us to create a more complicated fraction, one with a very specific numerator and one with a very specific denominator. And we also created a fraction runner, something that just created some fractions. So what I need to do now is I want to talk about the concept of accessing this information. I want to talk about how do I get information out. After all, these things are private, which means only the fraction class can manipulate these variables. And the way that we access this stuff is through something called an accessor. In other words, we're going to create a very specific way to get the data out of here. So in other words, my numerator is private, but there are some situations where I want a person looking at this fraction to be able to peek in and see my numerator. Not touch it, but just see it. Just be able to look at it. And so I'm going to have a method called getNumerator. And I want this to be a public method because I want other people to be able to get my numerator, to look at it, to peer inside and understand the depth of my fraction nests. And because my numerator is an int, when anyone says, "Hey, what's your numerator?" I want to say, "Hey, it's an integer. Here it is." So I've got this header. This is public int get numerator. And so what I need to do is I need to say, here's a copy of my numerator. You can do whatever you want with that copy. I'm holding the real numerator. No one can touch this numerator that I have. And so I have to write code for that. And it's fairly simple to do. It's one statement. What I'm going to do is I'm going to return numerator. Now, one of the things about Java is that it doesn't actually return the memory location. I'm not going to even tell you where my numerator is in memory. What I am going to do is I'm going to give you a copy of its value. And it's something very important to know is that Java passes these primitives by value, not by reference. So you don't know where in memory my numerator happens to be located. All you know don't know exactly where my numerator is in memory. All you know is that this is what the numerator happens to be equal to right now. Because later on, we're going to talk about how do I change my numerator. Like what if I add myself to another fraction? That would change my value. Or what if I subtract or multiply or divide? What if I even reduced myself? That certainly would change my numerator's value. But here's what my value is right now. I'm returning numerator. And the key thing to remember is that I'm giving them a value. I'm not giving them the variable. So this is something they can change later, and it doesn't affect me at all. And I need to create another accessor. It's also going to be returning an int because it's going to return the denominator. So this is our get denominator method. And it's very, very simple as well. It's just return denominator. So I have these methods that allow me to get information out of my fraction. So I'm going to go ahead and compile this real quick. And I'm going to go to my fraction runner. And what I want to do is I want to system.out.println f.get numerator. So what I'm doing is I'm telling f, fraction f, which is from our default constructor, yo, f, what's your numerator? And I'm going to get a value back, and I'm just going to print it to the screen. And remember, because this was our default constructor, our default numerator was 0. And I can do the exact same thing with pi and with better pi. And I will get all three of those numerators, 0, 22, and 355, respectively. And I could do the same thing with denominator now, because I've written a get denominator method. So I know that my denominator for better pi is 113. So what I've got here is I've got an accessor, a way to peer into the fractions and get some of that information out. The other accessors that I want to write, there's two other accessors that I want to write. One is, because we're dealing with a fraction has a value. And the way I find my value is taking my numerator and dividing it by my denominator. So what I'm going to do is I'm going to create a method for this. Now, most fractions have a decimal value. So I'm going to go ahead and make its type double. And this is going to be get value. And it's really nice to start your method titles with a verb like get, or set, or put, or do something. Remember that our bug had methods like move and turn, nice verbs. And I want verbs for these methods as well. Get the numerator, get the denominator, get the value. And what I'm going to do is I'm going to calculate the value. So I'm going to go ahead and store it in a variable. So double value equals, and I need to make sure that this is not an int, a double. So I'm going to need to cast one of these values. Now, if I cast the numerator, then that numerator is now a double, and if I divide by my denominator, that promotes the denominator to a double. So I've got a double divided by a double, which is a double. And then I want to return value. So I've assigned it to a variable, and then I've returned that variable. That's kind of wasteful, actually. What I actually would like to do is just jump and skip the middleman. Why create a variable when I could just say, hey, calculate this result and return this result. Much easier. Okay? So I'm saying, hey, calculate what it would be if I took my numerator and divided it by a denominator as a double and return that value. So what I've got here is I've got a method called getNumerator. So this accessor accesses the numerator. I've got an accessor called getDenominator. This gets the denominator value. And then I've got another get value, which gets the decimal value of the fraction. Now, this is something that's actually interesting. I never told the fraction how much it was worth. I never told the fraction how big or how small it is. I never told it its value. But it has a way of calculating its value based off of the numerator and the denominator. So I can compile this, and I can say over here, system.out.println, I want to tell pi, I want to get your value. And I want to do the same thing with better pi. And I talked about how pi and better pi, these are both approximations of pi, and notice here's my pi. This is 22/7. It's 3.142857, and it's a repeating fraction. Here's my better pi, 3.14159229. So it's a really good approximation of pi. Remember that I can system.out.println math.pi, and I can actually see what the value of pi is by bringing out math.pi. Notice that this value is very, very close. I mean, it only differs in the 7th decimal place. So this is a really good approximation. There's one other accessor that I want to do for this fraction class, because it would be very convenient if I could just go over here and say, hey, system.out.println pi. Just print out pi. And the thing is, if I try this, Java has no problem with it. I'm not going to like the result, though. Because what it does is it tells me, hey, this thing you asked me to print out, it's a fraction, and here's its location in memory. And its location in memory in this one instance. The next time I run this program, it may be in a different memory location. This is not helpful. This is not what I want someone to see when I look at a fraction. When I look at a fraction, I want to see a 22 divided by a 7. That's really what I want to see. So I need to tell Java how to do this. And the way I do this is through a special type of accessor, which is going to get the printed form of a fraction. And the name of this accessor is toString. And of course, I'm creating a string that represents the fraction, because a fraction has a numerator, and then it has a slash, and then it has a denominator. So what I have to do is I have to construct a string. So I'm going to go ahead and say a string output gets, and to construct a string, I'm going to start with my numerator, and I'm going to add a slash, and I'm going to add a denominator. And then I want to return that output. So this is one way that I could write it, but just as we did with the value, it's much easier and it takes up less memory if instead of storing it in a variable, I just decide that I'm going to return the result of this calculation. Return numerator plus a quote slash quote plus a denominator. And this is just something that we do to make things work out. So now if I try to compile this and run fraction runner, now when it prints out pi, I'm going to see that 22/7. And if I ask it to system.out.println better pi, it's going to print out the 355 over 113. All of these are accessors. They access the data in the class. Notice at no point am I trying to change the value of the fraction. I'm just trying to access the data within the fraction. So we had four accessors that we wrote for this. One accessor for the numerator, one accessor for the denominator, and these I'm just getting the value that's stored in the instance variable, getting the values that are stored inside the fraction. And then I had two other accessors. One accessor called getValue, which actually calculated the value of the fraction and gave it to us to use as a double. And one that actually got the printed form of a fraction. I concatenated a string, and I return that string. So we have accessors as a tool, ways to get information from a class. So our next step is how do we put information into a class? Because fractions aren't forever. We add, subtract, multiply, divide, take the reciprocal, we reduce. We are always making changes to these things. And so we're going to talk about that in our next video. So once again, this is Mr. Potter. Thank you for watching. Have a great day.